Hello everyone, and in this video today we will talk more about VOP VEX operators, and we will dive in details of some of the nodes in the VOP. And this video is really important because we need to understand the very basics of some nodes and how the nodes read the parameters from the global input and how it writes. In the last video, we created an attribute by the VEX and the VOP both, but in this video today, we will understand VOP in a much more detail. So together we will create a simple animation and we will understand how multiply works, how matrix transform node works, and how we can manipulate some attributes with these nodes. So let's jump directly into the video. And I have created this small animation, and you can see we have something like this. And I will create this exact, and I will tell you how I created this and why it is important to understand some of the nodes. So let's create a circle first. Okay, forget about that what I created, just focus on this. This is really important. So when I give this a z explain, now we have our circular pyramid, right? And you see it is made up of a circular ring with a primitive inside, and we need the outer circle, just the outer circle, not the primitive. So what we can do, we can say arch type to open arc, and we can increase the divisions so it can be a smoother circle, and arc angle we can decrease the maximum value, like the end value, so we have the separation like this, because we need to see where the arc separates. After this, I will create a sweep just to have a visual interest, and you can see it's a circle. We can give this square tube and single polygon end cap, and we have something like this. We can have some like tapering at the end. You can have something like this. Okay, this is okay. And column, you can decrease the column. Now we have something like this. Now I want to transform this. I want to have some changes in this. I want to manipulate this geometry by VEX operator at the VOP level, because at the VOP level we have more freedom to control our geometry, and I will show you how. First, we need to go to the VOP level. So attribute VOP, right? I've talked about this in the last video. And inside this, we have two default nodes. This is our input, this is our output. We read the parameters, we read the attribute parameters from this node, from the global scale, from the global geometry, and we write from this node. So first, let's say I want to translate this. Very simple. I want to translate this in X or Y or Z direction, or I want to like rotate this. So we need to give this something like, first we need to read the input, like where are the points located. So to read the inputs, we need matrix transform node. We can read the inputs. This node is like the transform node. So I said like we need to read the inputs, right? Whatever we do, we first need to read the input, so we can know where the points are located, what we need to change, right? Whatever you do here, you need to read the inputs first, right? So after that we can have the changes we need. So you can create any node, right? You can create any node first, but first you need to read the inputs. So I created this transform node, and we have two transform nodes here. Transform first this node, and we have this transform matrix node. This is a simple basic transform node. You have much less control over here, but you are like playing here with the matrix itself. Matrix is the number tables. Like if you have a point and we have its position x, y, and z, right? We have its position where the point located in x, z, and y. This is the matrix. You have its color RGB. So we have three values for like each color spectrum, right? So we have R, we have G, we have B. So we have this simple and we have this fully control. You can control everything from this is much more in deeper level, this matrix transform. So delete this. For this video we will use this matrix, and I will show you why. Because I need to like give I need to make changes in the CD value also and time, so we can have much more control over here. You can put this time value into this and then output. That's why we are using the matrix, because from this matrix we can control our geometry on a deeper level, on a more complicated way, sophisticated way. So we have this. First we need to read the inputs, right? So connect this p like the position vector to its position and output to p, right? So we have this, and check this, and when we disconnect this, uh, we shouldn't read the geometry, but yes, we are reading. First let's disconnect this, and let's say I want to make the changes in the rotation of this. Let's say I want to have a constant, and in this value give this to rotation, and you say this value should be 1. So now that this should rotate this geometry into like x, y, and z by the value 1, right? But we need to read the value first so it can know what we need to rotate, like what value should I add 1 in. First read the position. Now you see it has rotated. So when you give this when you increase this value, you can see now it is rotating our geometry, right? And delete this. Now we know we need to read the like position first. Okay, we can read any parameter here, but for this I need to read the position first to make any transformation changes here. So I have this position, and I need to have the time. I need to have time and rotation like connected with each other, directly proportional to each other. Like if I change the time value, my rotation value should also change. So what I mean by that, you would understand here. Let's say connect this to this. We have an issue here. The time is not a vector. Time is not a vector. It is just a float value. We have a value. We have 1 second, 2 second, 2.5 second, 2.35 second. But we don't have the proper vector x, y, and z. So first, what do I need to do here? Everything you do here, you would do in matrix x, y, and z with values, with proper accurate values. So we have just a number in time. We are in, let's say we are in 24 frame in the this animation bar. Like in the time bar, I am in like 24 frame. So we have just a number, a float value, a 24.2, right? So first I need to convert this. So to convert this, we have float to vector. I will convert this float value to vector. Now in this VOP node, in this node, we have 3, float value 1, float value 2, float value 3, and a vector output. This is three inputs we have for X, we have for Y, we have for Z, right? We need three values to come to make this in a vector, right? So time is just a number. When I connect this to this, the output would be, we have time, let's say 5, the time value is 5 now. So 5 is getting out of from this point, this 5 value is getting out from this point and going into the float value 2, which means y. So now the output would be x0 because it is not connected to anything, so its value is already 0. And this float value 3 will also be 0 because it is not connected to anything, so it has no value coming into this point. The output would be y equals to whatever it is. Time is directly proportional to this, like it is direct, like this is this, this is this, float value 2 is this 5. If I go 24, now float value 2 is 24. When I connect this to this also, now these two have value of 24. Okay, I think you understand this. And when I connect this value into rotation, into rotation, you would see now time has affecting its rotation value. When you go here, you see rotation has been grayed out because it is connected to the time. If time changes, rotation also changes. And what I want to do here, I want to just I want to, I want time to just affect the y value of this rotation. When I connected this in the rotation, and now the time value is just affecting the y value of this rotation, this value. So rotation x and rotation z is by itself 0. So when I play this, you see it is rotating according to the time. But it is like when I turn this real time toggle on, you would see it is moving so slow. We can have like another input in this, so we can have like a multiplier. Right now the value is 3, but if I multiply this 3 value by 10 and I output that value into this, so we would have like much more faster rotation. What I mean by that, I would like just do it here. Let's say I want to multiply something. This multiplier node is just math. It is multiplying two values. When I have one input, let's say I want to multiply this number and the product should be in y. First, you need to understand that we are multiplying the vector x, y, and z. The x value is 0, y value is 0, z value is 0, y value is directly is connected to the time, so the time is like the y value. So when I give this a constant value in the input 2, so now the value coming from this time is going into this input 1, and the value coming from this constant is input 2, and they are multiplying by like they are multiplying with each other. So let's say we have 10 and I have this constant value of 10. So now I have the multiplication and product is 100. So the value coming out from this product node is 100, and it is directly going into the rotation. So when I play, you would see the value has, like the animation has a bit faster, has become a bit faster. So when I give this value like something 100, so now the value is coming out from the time is multiplying directly, like it is multiplying by 100, and the output is going into the rotation value, so rotation input. And when you play this, now we have a much faster animation. And why is this important? Because we need to understand how these value connect with each other, how these values are working together to create this animation. Time is connected to this, it is converting into a vector form, and we have only the y value, other values are 0. And other values are 0, that's why it is not rotating in the x and the z direction, because they don't have a value. What if I give this a z value also? So now the time value is going into this and this also, and now we have a vector x, y, and z with values x0, y1, and z also 1, and they change when the time change, right? So now when you play this, you see it is also rotating in the z direction also. So for I wanted to show you something by this experiment, that how these nodes work together to create something like this. Now I have one question. What if I connect this output into the CD color diffuse value? Why are we seeing these colors when we are like transforming the rotation value, and how it is affecting the CD value also? I want to tell you here. Uh, I want to share a very important thing here. This output node is giving a value, a converted changed value. So this node is connected to its position parameter. So this position parameter is now like showing us the values, the position of each point. Like we have made changes in the rotation. Let's say you have made these changes in the rotation by this, and we have the rotation has now been changed, and rotation has now new value. So each point has been shifted by this rotation. Now each point have its own new position value x, y, and z in this 3D plane, right? So in 3D space, sorry. And I am now outputting this value into the P. If I disconnect this, I won't see any changes, because the changes are here. They are not going anywhere. When I connect this to this, now the changes that has been made in this now going into the P. That means that's how we are changing. Without the connection, we won't see the results, because the results are here. We need to give them where I want to see those results, in the position, in the CD, or where. So I want to share a really important thing here. Values coming out from this node, right? This output, there are values. We read the position of each point through this, and we have made some changes in the rotation of this, and now we have x, y, and z values coming out of this node for each point, right? I have connected those values to CD also. Listen to me carefully. We have, let's say you have a point, and the point lives in x, y, and z in the 3D space, right? It has three values. When I connect the position value of that point directly to the CD value, now the CD value has become the position value of that point. What I mean by that, CD color diffuse has three values, R, G, and B, and these three are vectors. They all three are vectors, and x, y, and z, the position value of that point, is also a vector. So now we are like connecting those three vectors, right? So now the CD value R, G, and B is x, y, and z. The R is x, y is G, and z is B. Now the R has become x, and the G has become y, and B has become the Z value. So I would write it here so you can understand it better. We have position P, let's say X, Y, and Z, coming out from this parameter, this position parameter, and we are reading this value now. And we said connected, we have connected this to like CD, which is R, G, and B. So now you need to understand this. The R is equals to X, G is equals to Y, and B is equals to Z. How do we see a color? We have three main colors, R, G, and B, and every color we see, and every color is made up of these three, like in a proportion. These three create all the colors that we see, R, G, and B. If we mix these three in like different proportions, we see different colors. So we have three values, R, G, and B. So now when you connected this to this, now you have these values equals to this. I want to show you important thing here. When you go to geometry spreadsheet, you see when I haven't connected this, we don't have any color diffuse attribute, and but when I connected this output value to the CD, now we have R, G, and B as exactly the same as we have the position vectors for each point. Let's say this, you have the same value as the position. So it's really important here. When you connect the output to this, now it is reading the same value as that. And one more important thing here, when you play the animation here, you see the colors are also changing, right? And here, really important, what if I like disconnect this? We would see the colors as they are, right? Because we are seeing the position vectors. And when I connect this into the position, we don't see anything because we are not reading anything, because we need to read the position of the points to make any changes, right? That's why we have the rotation and translate on the separate point. This, and I want to rotate this, and now you can see we have our different colors and our rotating geometry. But what would happen if I disconnect this and connect this output directly to the CD? Now you are seeing this, only this color. And when you decrease its value, wait, let me give this, I only multiply this to by 1. I only multiply the time value by 1, so we can see our colors. I want to like share here one thing also. The input that is coming out from the float vector node is now only Y and Z. We need R because we have connected this into the CD. Now CD is reading the values coming out from this vector, right? Which is R, G, and B, which was X, Y, and Z. And we now connected the CD. So before connecting this output product into the CD, we have the values X, Y, and Z. Now CD, which has R, G, and B, now reading the values coming out from this node, which is X, Y, and Z. So when I give this time, the R channel also, we can see our colors now. Just disconnect this so we can have our colors. This is the blue channel now, and I want to show you one more thing here. You see when we have these colors values, right? So these values together creating a color. So when I increase this, these values are also increasing, and when you go to scene view, after this value has become so greater that it is creating this color. So I want to like share one thing. When I connected this into the rotation and this output into the CD, we were seeing this like this spectrum where we have these colors, red and this pinkish bluish, and it's going into the green section. And when I give this a 100 value, and when I give this the 100 float default value, and when I play this, you see the colors are changing, but they are not going to an extreme level. And here, because we have a reason, and the reason is because the output product is going into the rotation, and rotation acts like a loop. We are going from value 0 to 360, then we are like going back to 0, and then we are going to 360. So when I play the time frame, you see our CD, value is changing, but they are going to 0 again. But they are going to 0 again. You see. So I think that's it for I think that's it. And when I show you what I created, it was the same. I have also like created some notes, and how I created this geometry with some this visual interest. You can see I have just I guess I just gave this a full twist, and it worked. So I made some changes here, and I know you can do it too because I have already talked about this a lot. And what I did this here, you see I have created some notes, so you can see connect P to translate value comes from the input. So the value that is coming from this position parameter is going into this position, and now we are reading the position of each point, and because of this we have made the changes we have made, like the time that we connected into this, and this is now going into the rotation. That means the rotation value is directly proportional to the time. If we change the time, our rotation value also changes, and I have also connected the output to the CD. So now the CD value has become the output value the time has been giving. So the position P, we are reading the position of each point of the geo, then we are connecting it to the Xform, which is transform. And I will give this, I think I'm going to give this project to you in the last video of this series, so you can like go to each project and see what I was doing. And we have two options. We can multiply this input into the input 2 or input 1, and the product would be in the rotation. But we can put this node before this or after this, and here are the consequences. Multiply after float, you would like multiplying the whole matrix with speed, and speed is this parameter, this input. And how I created this is just a parameter like promote. I have promoted this into the, I can show you right now. When you go here, you have this input, you can just delete this. You can put this value in the geometry level, so you can tweak this value from there. How I created this, go on this point, middle mouse click and promote parameter, and double click to show this promote, and you can change it to speed. And when you go at the geo level, you see now you have your wait label wait, input 2, and I should give this speed. So when you go into the attribute level, you see your speed value is here. Now this speed value is this input, this is this input, and this is on the geometry level now. So you can change the speed value from here, and you can have a float range from where you want, from the minimum to the maximum. And that's it, I guess, for this video. And I have just duplicated this, and I have given it a transform. You can see here this is the duplicated version of this. You would see the nodes are exactly the same. I have just given this a transform, and I have scaled it down. So you can see like I have this is scaled this down, so we can have three geometries. So, and in this geometry I have just uh, like from the time value I have given the x and the y value also. And when you see it here, it had the x and y also, but in this I have changed the value. From this is the value is how much is the value, 50. Here we have 100, and here it has 10. And when you go inside this, now the input is x and z direction. Go to this, toggle this on, and when you play this, you can see something like this. I know I was a bit messy in this video, in my articulation and in my explanation, but if you like really try to understand what I was saying, then you can understand this. And I will try to be more like good in explaining things, explaining concepts, but I'm trying my best to explain you, because this is really important to understand, and this is what creates the difference between who is just following the tutorials and who is learning on a deeper level. So in the next video, uh, I will I will like share something more of this VOP level, because these nodes are really important that we should, and it's really necessary that we should understand these nodes in a deeper level. If you have any questions, you can put in the comments, and I will see you in the next video. Bye bye.